This is the next way by which you can be asked to form an equation. And you can also be asked this little proof. I've seen this asked in the past. And in this question, the x or the y-axis is a tangent to the circle. So what happens if they tell me the x-axis is a tangent to the circle? Well, if the x-axis is a tangent to the circle would look like so. Obviously, I didn't fix this last night. All right, so here's the circle. And I can see that the x-axis is a tangent to the circle. What happens in this case? Well, the center of the circle is minus g minus f. And that's the radius of the circle. And the radius is, if it's minus g minus f, let's say that's 5, 3. Well, then the radius is 3. If that was 10, 7, the radius is 7. The radius is the y value. So the radius is the length of minus f, because the x-axis is a tangent. Now, I hope you understand that, because if you don't understand that, you won't understand anything. If that point was 5, 3, there, that's 5 and that's 3. But the 3 is the radius in this case, because the x-axis is a tangent. So I know that the radius I know is the square root of g squared plus f squared minus c. And I also know the radius is equal to whatever the positive value of minus f is. Therefore, the square root of g squared plus f squared minus c is equal to the length of minus f. Square both sides. G squared plus f squared minus c is f squared. They cancel. G squared minus c is 0. So g squared is equal to c. And you've got to know this off. If the x-axis is a tangent, well, that means that g squared has to be equal to c. And I hope you would understand that little proof. Right. The next thing is what happens if the y-axis is a tangent. Now, in class, I would give you this as your own little exercise to do. But seeing as we best keep going, I'll do it for you. And then you can record the videos yourself again if you wish. Y-axis. Y-axis is a tangent. Center of the circle, the minus g minus f. And that there is the radius. In this case, the radius is equal to the length of minus g. How I would explain that in class, if that's the point 3, 7, well, that's 3 and that's 7, right? The x value corresponds to the radius, if that's the 3. The x value and the radius are the same. So I can say the radius is the length of minus g. I also know the radius is the square root of g squared plus f squared minus c. Therefore, I can form the equation g squared plus f squared minus c is equal to the length of minus g. That's if the y-axis is a tangent. Squaring both sides, g squared plus f squared minus c is equal to g squared. They cancel. F squared minus c is 0, or f squared is equal to c. And we see that f squared is equal to c if the y-axis is a tangent. And g squared is equal to c if the x-axis is a tangent. If they tell you the x-axis is a tangent, you can automatically assume that. You don't have to prove it. If they tell you the y-axis is a tangent, you can assume that. You don't have to prove it. If you have to prove it, that's all you do. But the proof of that is, once you understand what's happening, that's pretty easy. Now, that's the third way by which you can form an equation. So now we have three ways you can form equations. You can form an equation by giving a point on the circle. You can form an equation by saying the center is on a line. Or you can form an equation by saying the x or y axis are tangents. So now, how would this impact in a question, and what would the question look like? Here's a question. It says, find the equation of the circle which contains them 2 points and has the y-axis as a tangent. Well, y-axis as a tangent, I know straight away that f squared is equal to c. I'm not asked to prove that. So let me draw a little diagram of this to see what it would look like. Again, very important for you understanding what's going on, whether you draw it or not. My advice to you would be, if you can, draw it quickly. It's always better to know what you're looking at. There's 2 minus 5. There's 2, 3. And the y-axis is a tangent. The y-axis is a tangent. The circle will look something like so. Yeah, and so there's your circle, something along that lines. Center in and around here someplace. So I can't find the center and the radius, so I use equations. The first equation, as I says, I know 2 minus 5 is an element of x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So I get 4g minus 10f plus c is equal to minus 29. If I'm wrong, tell me. The second one I know is that 2, 3 is an element of x squared plus y squared plus 2gx plus 2fy plus c equal to 0. And I'll get 4g plus 6f plus c equal to minus 13. And my third equation is, I know that f squared is equal to c, which is the same thing as c is equal to f to be squared. All right, now I'll go back to the last page when I finish this. Okay, so now I have 3 equations. This isn't an xyz and xyz because of this c is equal to f squared. So if c is going to become f squared, right, what I need to do then is I have to get g in terms of f. So let me show you. Between 1 and 2 we eliminate c. 1 and 2. 4g minus 10f plus c is minus 29. And to eliminate c, I minus that one. Minus 4g minus 6f minus c is equal to 13. Be very careful with these type of Go back and check that. Minus 4g minus 6f minus c plus 13. The g's cancel and the c's cancel. That's very nice for me because I get minus 16f is equal to minus 16. F is minus 16 divided by minus 16. F is 1. Now, therefore, I know that f squared is equal to c. 1 squared is equal to c. 1 is c. So now I can just go back and I have f and c, I can get g. 4g plus 6f plus c is minus 13. 4g, 6f is 6, and c is 1, is minus 13. 4g is equal to minus 20. G is minus 5. So therefore the equation of this circle is x squared plus y squared plus 2gx plus 2fy plus c equal to 0, which is x squared plus y squared plus 2g minus 10x, and 2f is 2y and 1 equal to 0. The center of this circle is 5 minus 1, and I marked a point there. That's where I said the circle is in and about. And 5 minus 1 does match up with that, so it does. What happened here? Okay, so there is the equation of that circle. Now, it doesn't normally work out this simple here. So I might get another example that the equations are a little bit harder to solve to show you what happens there. But that's how the x or y axis is a tangent to the circle. What have I next? All right, and this one might help me demonstrate what I'm doing. The fourth way, what's happened here? Okay, you're all still there. The fourth way by which you can be given an equation is you're told the length of the radius. And the radius is the square root of g squared plus f squared minus c. Just say the radius was 5. You'd say the square root of g squared plus f squared minus c is 5. You square both sides. You get g squared plus f squared minus c is equal to 25. That would have been your equation. So now, the fourth way by which you can be given an equation, I'll just write it back here where I wrote previously in my notes. Yes. The point on the circle, the center on the line, the x and y axis is tangent, or that you're given the radius. And that's the fourth way you can be given an equation. There's a kind of fifth way that we'll come across as well. So here's the fourth way given the radius. So I'll do an example. Find the equations of the circles that contain the points 4, 2, 3, minus 1, and have a radius of 5. So a little diagram to show you what's happening. Now you'll see now in a minute we'll get on to the papers. And these come up a lot in the papers. 4, 2, 3, minus 1. So the equation of the circles contain the point 4, 2, 3, minus 1, and have a radius that is 5. So here's a radius that is 5. So I'd say there's a circle around here someplace. I don't need this perfect now, just to show you. So there's about one circle. Yeah. Satisfies all my criteria. Goes through 4, 2. 3 minus 1, and it is a radius that is 5. Of course, there is another such circle that would satisfy that, and that would be going the other side. That circle. So in this case, I'd expect to get two different circles for my answers. That's another circle that goes through 4, 2, goes through 3 minus 1, keeps going along, and it also has a radius of 5. So that's what we're looking for. I can't find the center and the radius, so I must form equations. My first equation is that 4, 2 is an element of x squared plus y squared plus 2gx plus 2fy plus c equal to 0. I'll get 8g and 4f and c equal to minus 20. Just make sure I have those right now before I go on. 3 minus 1 is also an element of x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So I'll get 6g minus 2f plus c is equal to minus 10. And the third step is the radius, the square root of g squared plus f squared minus c is equal to 5. So that's giving me g squared plus f squared minus c is equal to 25. So what I've got to do now in these type of equations, this is linear, and this is quadratic. So what you do in these ones is you change the quadratic into one variable. So I start with g squared plus f squared minus c is equal to 25. So I have to put in this into all g's, all g's or all f's. That's what I have to do. So I go back to these two equations. What can I eliminate between them? Well, let's eliminate c. So between 1 and 2, I'm going to eliminate c, and let's see what I get. 8g plus 4f plus c is minus 20. Minus this one, minus 6g plus 2f minus c is 10. Now let's see if that minus plus minus plus. I'll get 2g plus 6f is equal to minus 10. So that would mean g plus 3f is minus 5. So g could become minus 5 minus 3f. So g could be minus 5 minus 3f. So instead of that g, I'd have minus 5 minus 3f to be squared plus f squared minus c is equal to 25. Now this minus c is the problem. I have to get c. So what's c in terms of f? I have to eliminate them g's. So between 1 and 2, I'll get rid of g. So I'll have to multiply 1 by 3 and that by minus 4. 3 8s are 24g plus 3 4s are 12f plus 3c is equal to minus 60. 24, 12, 3 minus 60. Minus 4 minus 24g. Plus 8f minus 4c is equal to 40. Is that correct? Minus 24 plus 8 minus 4 plus 40. And I will get 20f minus c is equal to minus 20. So 20f plus 20 is equal to c. So now squaring this, I'll have 25 plus 30f plus 9f squared plus f squared minus c minus 20f minus 20 is equal to 25. There's my quadratic, 10f squared. 30f minus 20f is plus 10f. They cancel. Minus 20 is equal to 0. F squared, this is wrong, 25, 30, 9f squared plus f squared minus 20f minus 20 is equal to 25, 9f squared. I get an f squared plus f minus 2 equal to 0. Sorry, it's not wrong. It's f by f is equal to 0. F plus 2 minus 1. So one value is f is minus 2, and the other value is f is 1. So they're giving me the f values of my centers. Yes? So down 1 and up 2 looks right here. So now I have my f values. But coming back to this question, it's how you think. And what I mean by this is, when you get equations that are GFC, GFC, and quadratic, all right? So if I go to solve this, if I get linear, linear, quadratic, how you solve that one is that quadratic all becomes one variable. So I have to use the other two equations to change it all into one variable. Once I know that that's what I'm trying to do, this maths then is pretty straightforward. It's solving a quadratic equation. That's what you're going to have to do. Now, when f is minus 2, g is minus 5 minus 3f. So therefore, g is equal to minus 5 plus 6. G is 1. When f is 1, g is minus 5 minus 3. Minus 5 minus 3, which is minus 8. So 8 and 1, that looks right again. And then to get the corresponding c value, the c value is 20f plus 20, which is 40. And the c value is 20f plus 20, which is, no. The c value is 20f plus 20 is 40. The c value is 20f is minus 20. And GFC, GFC, they give me then the two circles. Ooh, do you enjoy that? So that would be kind of, I think, nearly too hard for your Leaving Cert. Not too hard, but too long. So what would I expect you to get? Well, not equations this length. All right. So that's that. Again, it'll be recorded and put up for you. I'd just like to give you maybe a little note. And I want to give you two notes that will help you in the circle. And now I'll go on and do some Leaving Cert questions with you. If I give you the tangent, you know that the perpendicular distance, if I tell you it's a tangent, you will say to yourself, the perpendicular distance from the center to the tangent equals the radius. And the second piece of information that we haven't dealt with and can be used a lot now, if your teacher gets time to do all this, this would come up a lot. If I give you a chord of a circle, and that's the center, and this is a chord, it's the portion of the secant that's inside the circle. And if I draw a line from the center perpendicular to the chord, it cuts the chord in half. So that's the theorem. A line from the center perpendicular to the chord bisects it. But the reverse is also true. The perpendicular bisector of a chord will pass through the center. A perpendicular, that line, the perpendicular bisector of the chord will go through the center, and the center is minus G minus F. You will definitely use that in a lot of exam questions, and that is an option quite a number of times. So it's